Alright guys, today we're looking at finding the volume of solids. Solids is just the name for a 3D shape. So like this is a 3D figure on the paper. Of course paper is 2D, but it's a drawing of a three-dimensional figure. The dimensions are length, width, and height. Okay, so you can always remember to find volume, it's length times width times height. And you can remember each one based on how it looks. Length is the side to side, like the bottom of the L. Width are your diagonals, like the diagonals on the W. And height is your straight up and down, like the two lines on height, on H. So if we're looking at that, height is our up and down here. This is our height, and our height is 2. This is our width. Remember, the width is diagonals. And our width is 1, 2, 3, 4, 5. And then we have our length. Our length is our side to side, like the bottom of an L. And the length is 1, 2, 3, 4. So if we wanted to find the volume of this, we would multiply our length times our width times our height. Now, when we're multiplying our length times our width, we're basically finding the area of the base, the bottom layer. So if I'm going to multiply my length times my width, I'm going to get 20. Now I need to multiply it by the last part, my height, which is 2. So 20 times 2, 2 times 2 is 4, 1, 0, 40. So the total volume of the shape is 40 cubic units. And whenever we do volume, we always say cubic. Kind of like when we do area, we always say squared. For volume, it's cubic. Next, we're going to look at these shapes. These don't have cubes to count. They already have the sides labeled for you. Now, this one has, remember, the diagonal is your width. The side to side is your length. And the up and down is your height. So we're going to multiply 6 times 6 times 5 to get our volume of this figure. This one over here, though, it doesn't have a length and a width. That's because 72 is the area of the base. Remember, area is just length times width. So if we found area of the base, length times width is 72. Then we just need to multiply it by the height. In this case, our height is 9. So we would multiply 72 times 9, and that's going to get our final volume. I got 648, and so 648 is the total volume, units cubed. Okay? So if I'm looking back at this one, first I want to do length times width and get the area of the base, this whole bottom layer basically. That's 36, and then I'm going to multiply the area of the base times the height, 36 times 5. And our total volume is going to be 180 cubic units. Finally, we have these figures here, which have both cubes and space. The cubes are going to help us find the length and the width, and up and down, it'll help us find the height. Then we can multiply to find our volume. So if we look here, on this figure, we have our width, our diagonal, 1, 2, 3, 4, 5, 6, and our length is 2, okay? Now we need to find our height, which is 1, 2, 3, 4, 5. So to find the volume of this figure, we'd multiply 5 times 6 times 2. Now, on this one, we can easily find our length and our width down here. 1, 2, 3, 4, 5. 1, 2, 3. But it's not as easy to find our height. It looks like the height is 4. But in reality, there's underneath here, there's another cube hidden below. That's the cube that it's stacked on top of. Otherwise, it would just be sitting there floating in the air. So there's actually cube number 5 hidden under there. So the height, in this case, is 5. So to find the area, or to find the area of the base, we'd multiply 5 times 3, and then we'd multiply it by the height to get the volume. So those are all the different ways you can find volume depending on what your figure looks like.